Hello everybody. Today's lecture is about free fall. What is free fall? When an object moves and the force on the object is only the force of gravity. In other words, the force on the object is its own weight. Then this situation is called free fall. For example, if I drop something, all right, okay, I drop this pen, I just let go, so this pen will fall. So this is called a free fall, because the only force on this pen is its own weight. Suppose I'm not let this pen drop by itself. Suppose I throw it up. So throw it up. Okay, let me find an object so that I can throw it up. All right. Okay. I have an eraser here. So I throw the eraser up. What happens then? What happens to the motion? So the eraser will move because I must give it a push. Throw it up. So once I push it, it leaves my hand. The eraser push it, the eraser leaves my hand with a velocity, right? With a velocity. But that velocity will slow down as it goes up. It slows down, and then when it reaches a certain point, the velocity is 0. And then it goes back. Then it falls down, right? So when I push it up, when the object leaves my hand, the only force on this eraser is its own weight. So this is again a free fall. Don't be confused with the word fall, because this motion, at the beginning, it goes up. It's not a fall. It goes up, and then it falls down. The whole motion is still called a free fall, because the only force on it is its own weight. So that's the definition of free fall. Okay. So I have given you some examples of free fall. One is just let go. The next example is throw something up. When it doesn't matter whether it's falling down or throw it up, in free fall there is acceleration. So when the body moves down, it goes down quicker and quicker. Because the velocity becomes bigger and bigger, there is acceleration. The acceleration is obviously pointing downward. What is the value of the acceleration? The value is 9.8 meters per second square. And this value is obtained by experiments. Okay? So 9.8 meter per second square. So let's have some example of free fall. But before we do the example, one thing I must mention that because the free fall is up or down or just entirely down, it doesn't matter. It's a vertical motion, right? Therefore, before you do the problem, you must choose either the upward direction is positive or the downward direction is positive. It doesn't matter. It doesn't matter. Okay, let's have an example. The example is I have a building. This is the ground. The building is 52 meters high. So this is 52 meters. The building is 52 meters. I throw a ball. There is a ball here. So I throw the ball up. Throw the ball up with a velocity of, this velocity is 24 meters per second. I throw the ball up. Can you imagine what happens to the motion? You throw it up, it will go up. It will go up. But the velocity becomes less when it goes up, right? Until the velocity becomes zero. So suppose at this point the velocity is zero, then the ball is falling down, right? So the ball is falling down. And the ball will hit the ground. Okay, this is the motion. At this point, velocity is zero, right? Okay. So, what do we want to find? Part A, we want to find the velocity is what at this point. So what is the velocity here? When the ball hits the ground, what is the velocity? So let me write some subscript. Let me call this V1 and call this V2. So what is V2 now? V1 is the initial velocity. V2 is the final velocity. So part A, what is the final velocity? B. Part B. Suppose at the moment you throw it up, you call the time 0. You start from t0. That's very natural, right? time is 0 here. How do I label it? T is 0 here. At this position, T is 0. And then here, when it hits the ground, what is the time? What is the time when it hits the ground? In other words, I want to find the time interval from here until it's here. How long it takes? How long it takes? The time is what? At this point, what is the time? Next, what I want to find? I want to find, at this point, the velocity is 0. How high is this point from the ground? So I want to find this h. How high is the highest point? What is the height? That's part C. Part C. H is what? I have another part. So this is 52 meters. So somehow there is a height . 60 meters, right? 60 meters. When the ball is 60 meters from the ground, what is the time? Now look at here. You have two times, right? At this point, it is 60 meters from the ground. So at what time the ball is here? Then goes up to the maximum height and then it falls down. At this point, it is again 60 meters from the ground. So you have two times. One time is when the ball is going up and the height above the ground is 60 meters. But then you have second time when it goes down and then you again have a height 60 meters above the ground. So what is the time there? So what is the time when height is 60 meters? This 60 meters is above ground. 60 meters above the ground. So what is the time? So you have two times. Yes? One time is here, another time is here. So how do we do part A? So we need some formulas. This is a problem of kinematics because no force is involved. If forces are involved, we call it dynamics. But there is no force in this problem, so it's kinematics. In kinematics, we have three basic equations. In some textbook, usually in the textbook, there are 5 equations, 5 formulas. But only 3 of them is enough. So I usually tell my students, just remember the 3 equations. You don't need 5, just 3. What are the three? Let me write it down. The first equation is V2 equals V1 plus AT. The second equation is distance equals V1T plus 1/2 AT squared. The third equation V2 squared equals V1 squared plus 2AD. Okay. So these are the three equations you need to remember. And the best way to remember it is just like singing a song. So I already did that. So how do you sing that? This is a song. Just say it loud. V2 equals V1 plus AT. D equals V1T plus 1/2 AT squared. V2 squared is equal to V1 squared plus 2AD. So this is simple to remember. Do not remember the formulas in your textbook because that is too long and too complicated. Why I say that? Because in the textbook, they use delta t instead of t. In the textbook, they use delta d. And here is delta t. And here, this t is also delta t. So, and this t is a delta d. Do not say delta because that is so inconvenient. Let me show you what I mean. So the second equation, if you use delta, how do you say it? Okay. Delta d equals V1 delta t plus 1/2 a bracket t square close the bracket. Oh no. A bracket delta t bracket square. So why do you want to say delta? Make it simple, all right? Make it simple. All right, this is how I say it and how I remember it. Particularly the second equation, there is a complication in the delta t because you go to the textbook, delta d equals V1 delta t plus 1/2 a refer to your textbook. Don't you see that the delta t has to be in brackets? If you do not have the bracket, don't you know that this is different from that? Delta t means a time interval, and square the time interval. But this is what? This is the interval of t square. It's not interval of t. It's different. So the bracket is so important. Then, if you have the bracket there, how do you say it? It's too complicated. Do not use delta. Use my recommendation. Make your life simple. All right? Okay. Let's do the problem now. Part A. What is V2? Use this equation. V2 you do not know. But V1 is given. So in this equation, V1 is given. What is A? Okay. We mentioned the acceleration is 9.8. 9.8. The acceleration is downward. So we also mentioned one thing. Before you do the calculation, you must choose. Do you choose up positive or down positive? It doesn't matter. So let's choose up positive. Okay. Let's choose up. Up is positive. Therefore, V2 you do not know. V1 is 24. Okay. Do I block your view? So I stand here now. V2 you do not know. V1 is 24. A is negative 9.8. Because up is positive, but 9.8 is down, so it's negative. This A is negative 9.8. D. What is D? Oh, I must write a D. What is D? D is the displacement. How do you decide the displacement? Displacement is a straight line you draw from the starting point to the end point. That's the displacement. Remember, you draw from the starting point to the end point. Starting point is here, end point is here. So the D, displacement, is this way. How big? 52. Direction? Down. The displacement, the direction of displacement is down. Therefore, it's negative because we choose up is positive. So, V2 is part A, what I want to find. V1 is 24. A is negative 9.8. D is negative 52. So in this equation, this is known, this is known, this is known. I can find V2. Understand? So I'm not going to give you the detail. You can find V2 using this equation. And the answer is, V2 is, if you do that, V2 is 40. 40 meters per second downward. V2, of course, is downward, right? Yeah, okay, V2 is right. So part B, what is the time? The time interval from the beginning to the end. What is the time there? Okay, so how do we find that? You use the first equation. Because V2 you already found from part A. V2 I know. V1 is 24. A is 9.8. Time is what I want to find. Okay, let me say it more precisely. V2 is down, therefore it's minus 40. This is minus 40. V1 is you throw it up, so it's positive 24. Minus 40, positive 24, minus 9.8, you can find T. See? So, and this is part A, and part B. You can find that the time turns out 6.5. That's second. Okay. C. What is the height? Height is the distance. So let's use the second equation. Okay. So you want this height. How do you find this height? So let's break it into two parts. Find the height from the beginning to this point. Find this height. And then once you have this height, you add 52, then you get this height. How do I find this height? Look, at this point, velocity is 0. So, I can use the first equation. No, I use the third equation. Now, the third equation, V2 is not here. V2 is here. Okay. V2 is 0. V1 is 24. A is negative 9.8. And you can find D. Let me say it again. V2, because I want to find this height, therefore this is 0.1, this is 0.2. So V2 is a velocity here. But at the highest point, V2 is 0, velocity is 0. So this is 0, this is 24, this is negative 9.8, and then you can find the D. This D is from this point to this point. Understand? Once you have the D, add 52, you get this height. That's part C now. Then part C is part C is 81 meter. See, this is 81 meter. 81 meter. Okay. This H. Okay, let me write H equals 81. Okay. The height H is 81 meter. Okay. Then we do D. What is the time when the height is 60 meter? When this is 60 meter, what is the time? What is the time here, time here? So D So D is, okay, when this is 60 meter. Now, if this is 60 meter, what is the distance between the starting point and this point? So this is 60, this is 52, therefore this is 8. And this is our displacement. What is the time when the displacement is 8? So you put 8 here, put 8 here, and V1 is 24. T is what you want to find. A is negative 9.8. T is what you want to find. And look here. So T has a square there. Therefore, you end up with a quadratic equation. How many solutions for a quadratic equation? You have 2 solutions. Therefore, your T has 2 answers. This is exactly what we expect, because when the ball reaches this point, there is a time. When the ball reaches the highest point and falls back, reaches this point, there is another time. So you have 2 time, and this is exactly, you have 2 answers to the quadratic equation. So what do you have? So you have T equals 0.46 second, and T equals 4.5 second. So you have 2 answers. 0.46 second. This is the time when the ball reaches this point. When the ball reaches this point. And the next answer, 4.5 second, is when the ball reaches this point. So, I'm not giving you the detail of the calculation, but I mentioned what equations you can use to get the answer. So, that's the example for free fall. I hope you follow the steps. All right? So for the numerical answer, you can try it yourself. Put the numbers in the equation and find the answers. Good. Thank you for watching. I'll see you next lesson. Goodbye.